Okay, today we're covering 2.3 and 2.4. 2.3, let's see, that starts on, let me find the page real quick. 2.3 starts on page 127. It's factors. Okay, the factors of a number. Like you know that 6 is 2 times 3? 2 and 3 are factors. Okay, if you have to find all the factors of a number, it wants you to give the 1 and the 6, like 1 times 6, and 2 will go into it, 2 times 3. These are all the factors of 6. Okay? What are all the factors of 9?
3 times 3, 9 times 1.
3. And that's about it, right? And only put the 3 one time, even though it's 3 times 3. That's all the numbers that will divide evenly into 9. And don't get factor and prime factoring mixed up. All the factors is just all the numbers listed out that will divide into it, okay? We'll be doing prime factors in a little bit. Okay, this is factors. If a number has other than 1 in itself, it's called composite. These are composite numbers right here. Both of these are composite. Okay, a prime number, like 5, what will divide into 5? 1 and 5. That's a prime number because its only factors are 1 in itself.
Okay, so prime numbers.
Prime. Okay? Okay, a good way to remember the difference between prime and composite, have you heard of composite minerals? Like if you hear that a rock is a composite of lead and I don't know what would come with something with lead in it. I'm not a geologist. Say a rock has turquoise and it has gold and then other junk in there. Okay, that's a composite rock. It's got more than one thing in it. A prime would be something that's like solid. Like if you had a piece of solid gold, that's prime, right? That's like really good stuff. It's not all mixed up. Composite means it has more stuff in it. So your composites are the ones that have more than just 1 in itself.
More than
itself. Yeah.
What do you?
Composite is a composite of. See how it has more than just 1 in itself as factors?
So more than itself, composite
yeah.
than itself.
It's a composite of numbers. The prime is just the 1 in
like
itself.
The whole
more than one factor. Is that the word we want?
Well, more than itself is 1. Yeah, more than.
More than itself, and prime is by itself.
Prime is,
okay, can we say
like
more?
3.
More factors.
What are the factors of 3?
1 and 3.
1 and 3. So it's prime, right?
Right.
Have
How
more
about
factors
4?
than
2, 1, 2,
1, 2,
and 4.
4. So it's
a composite.
Composite. Yeah.
Oh, because it's got more.
Yeah.
Okay,
so
like
it's got more than 1 in itself.
Like 6 is 3
6.
times 2.
Yeah. So that's a composite.
6 times 1.
Right.
7? What about 7?
7 is
Seven.
prime.
Is it going to be a
Just
prime
1
number?
and 7. Prime. Right. Okay? Now you know the difference between prime and composite.
Yes, ma'am.
Barely.
Barely.
Oh, clear.
I'll give you a sheet that where you can have from
10
1
is
to
a
100.
composite.
I'll give you one.
Yeah.
This is
Oh,
2,
okay.
1, 2,
Okay.
5, and 10.
So finding all the factors, you know how to do that. You know whether to tell if it's prime or composite. Okay, now let's do a prime factorization.
Okay, where are you at?
Page 131, your homework, you're going to have 29 through 52 is where you do the prime factorization.
29, okay. Okay. So like
Okay.
So like H would be
Like 6 is 2 times 3. 2 and 3 are both prime numbers, so you can't divide them anymore. It's just 2
Where
times 3.
are you looking at?
Right here.
I'm just,
right
well,
here.
I'm just making
Oh,
it
no,
problem.
okay.
But there's a 6 there.
This will be for like the numbers 29 through 52. You'll be dividing them up.
And
You
divide
can do
them like
it like
that?
a tree, like this, or you could divide it, 6 divided by 2 is 3. Let me give you a few examples. I actually prefer this. I like this way better because you don't lose stuff. Although you didn't lose anything here, when they get bigger, you can lose stuff, okay? Let's do a bigger number like 150.
Okay, if you were gonna write that out, would that come out to
6 is just 2 times 3. That's how you would write it.
So the answer would be in the bottom or the
This
dividation?
is your prime factorization, 2 times 3.
And there wouldn't be
Either,
any
either
exponents
the
in
bottom
it?
numbers if you do it like this, or the sides in the top if you do it like that.
Okay, that's okay.
Okay, we're gonna do a few examples, okay? Okay, 150. That would be like 5 times 30, right? Okay, 5, you can't divide anymore, right?
Right.
So you're done, you can't, 30 you can divide. Like 2 times 15, or 3 times 10. And it doesn't matter, you could do 2 times 15, or you could do 3 times 10, or you could do 5 times 6. You could do any way that it divides when you're doing this. Just keep dividing as
You
long
want
as
it
you
long
can.
ways?
Oh,
I mean, you want
Okay,
it the
and
long
then
ways?
10, no, I don't. Okay, 10 is 2 times 5. Now see, all of these numbers right here would be the numbers you would use. The reason I told you I prefer this other way, let me do this doing the other way. Because see, this is all spread out. Okay, if you do 150 and you divide it by a prime, you can divide it by 2 or 3 or 5, it doesn't matter. Just whichever one you want to do. I just did 5 because it was easy to divide. 5 into 150 is 30. Make sure every time you divide by prime now, okay? Don't divide by 10, because 10 is not prime, okay? When you divide by prime. So 30 divided by 3
oh, you're going up.
is 10. Yes, I'm going out like dividing it like this. 10 divided by a prime, 2
2?
is 5. Okay, this way you got them all on the edge and up here. If you do it this way, you won't lose any. Like this, if you write real messy and there's some of these numbers, you might miss like the 3 here. You might think, oh, it's 2 times 5 times 5 and miss that 3. This way, you don't miss any. They're all on the edge, and when you get to the top, when you have a prime on the top, you're done. And then when you put them as your prime factorization, okay, start with the lowest number. The 2 is your lowest number. There's 1, 2. Okay, then the 3. And then you have 2 5s.
Oh,
You
you
could
use
write
both of
it
those.
5 times 5, or you could write it with exponents. The 5 you could write as 5 squared, because that's 2 times. If there was 3 of them, you could have put an exponent of 3. This is how you're going to see your answer, like written out like this or like that. And if everybody puts them in order from small to large, everyone's answer is going to look the same, no matter what you started with here. See, even though I started with the 5 and it's a 5, 3, 2, 5, if we put them in order, everybody's answer is the same.
But you want them worked out that way?
I prefer this way, but if you've done it this way and you like this way, go ahead and do it that way. I actually prefer this. Yes.
The way you did on the left, side, when you got to 30, what if we went 7 and 5?
Okay, let's
We'll
do
stop
it a
there.
different way. No, well, not 7 and 5, we should do 6 and 5.
6 and 5, yeah.
Yeah. Okay, divide by 5 is 30. What if we divide by 5? We can't divide by 6 because it's not prime. If we divide by 5, it's 6. When you divide 6, you're going to divide by 2 or 3. Divide by 2 and you have 3. So it's still 2, 3, 5, 5.
All right.
So you can do it in any order. You could have started with 2. If you wanted, you could start with 2, which is 75.
2
And then 3 3/4 is 75. 3 times 25.
So it doesn't matter
And then
what you divide,
It
as long
doesn't
as it
matter
divides
which order. Just don't
As
mess
long
up on your division.
as long as it divides into it
Right.
just right without a remainder.
Yeah, they're all gonna come
So
out.
5, 5, 2.
And once you put them in order, everybody's will be exactly the same.
So 5, 5, 2, 3. Oh, man.
See, we could have divided by 3 first. Divided by 3 is 50.
Bless you.
Bless you. Divided by 5 is 10. Divided by 2 is 5. See, there's still all those same numbers in there.
Wow.
If you want to check your answer, you can multiply it back. 2 times 3 is 6. 6 times 5 is 30. 30 times 5 is 150. It'll multiply back. That way you can check your answer.
Let's do another hard one.
So you want us to write it out, 2 times 3 times 5 times 5, or
Or the
exponents?
exponent.
Either
So you want
this
the
way
answer
or
or
this
not?
way.
All right.
Sometimes this way is a lot better, because if you have an answer that has like 2 times 2 7 times, it's a lot easier to write 2 with an exponent of 7, right? Let's do one that has a big exponent, maybe. Let's do, you're doing the even, so we'll do an odd one. Let's do 360. 360. You could tell it divides by 3, right? How do you know if the number divides by 3?
Because it has a 3 and a 6 in it, and a 3 will go into a 3, and a 3 will also go into a 6.
Right. And the divisibility test is to add them up. If you add 3 and 6, it's 9. 3 divides into 9. Okay, so 3 will go into it. 3 goes into 3, 1. 3 into 6, 2. Don't forget to bring that 0 up. 3 times 120 is 360. Will 3 go into that?
Yes.
1, 2, 3, yeah. 3 goes into 12, 4 times, bring that 0 up. No more 3s, huh? 3 won't go into 40. How about 2?
20.
2 will go 20 times. 2 again,
Yep.
Yeah.
10. And then 2 again
Yep.
is 5.
Oh my gosh.
Okay,
So you've got 3,
So-
3, 2, 2, 2, 5.
we got 1, 2, 3 2s, 2 3s, and a 5. Now, is that easier to write, or is
Yeah,
it
that's-
easier to write?
No, it's easier like that, 2 and 3
Yeah.
exponent.
See, there's the 2s, there's 3 of them. The 3s, there's 2 of them. And the 5s, you don't need to put a 1. Just put it 1 time. This is easier, right?
Right?
Yeah, and that's the way they want it, isn't it?
I'm not positive how they.
Yeah, it
fixed
says
on
right
the
with,
answer sheet.
right answers with exponent.
Okay, so they do want you to go ahead and switch it into exponent form.
So we would write it 3, 2 times, no, we would write it 2, 2 times 2.
2 to the 3rd power times 3 to the 2nd power times 5. That's how you say it. Okay? And that's pretty much all you do in 2.3. And 2.4, writing a fraction in lowest terms. Okay. Writing a fraction in lowest terms. That means you're simplifying it or reducing it, whatever you want to call it. Okay, they show a few ways to do it. If you have the number like 60 over 72. Okay, what will both of these numbers divide by? You can tell because it's even, they will divide by 2, right? Look at the last number, they're both even. Let's divide by 2. And you'll be better off if you write it here, because sometimes you get distracted, you divide by 2, you might forget and divide by 3 on the bottom. It has to be the same number on top and bottom. 60 divided by 2 is 30. 72 divided by 2 is 36. Can you divide that again? Yes. Even again, right? Since we can divide by 2 again, we actually could have divided by 4. But if you didn't recognize that you could divide by 4, that's okay. Just do it when it's the way it's easiest, okay? 30 divided by 2 is 15. 36 divided by 2 is 18. Now, can we divide that? By what? By 3. 15 divided by 3, 5, and then 18 divided by 3 is 6. 5 and 6, you can't divide by the same number, so you're done.
You have to be able to divide into both of them before you finish, right?
Yeah.
Before you
You have to divide both the top and the bottom.
So your answer is 5, 6.
5, 6. Actually, if you multiply everything you divide here, you got 2 times 2 is 4, times 3 is 12. You actually could have divided these by 12, but you couldn't see that right away. That's okay. If you could have seen and you knew that you could divide them by 12, you could have went straight to dividing by 12. But most people don't recognize that unless you happen to know your 12 times something.
Does the other calculator?
So, yeah, don't use the calculator.
Okay.
Just do 2s and 3s and the numbers that you can do, and that'll give you the practice of dividing too. And don't be relying on the calculator. Do it in your head. Get that brain in shape. Okay, 60 divided by 2, 12 is 5, and that was 6. So you could have done that if you knew it.
Oh, that would have been a lot shorter, huh?
Okay, they also show a way to get into lowest terms using the prime factorization, the stuff that we just now did. Okay, let's find both of these numbers, the 60 and the 72. Let's find the primes of them. Okay, let's do 60 divided by 2 is 30. 30 divided by 2 is 15. And now we need to divide by 3 because we can't divide by 2 anymore, right? Divided by 3 is 5. So the prime factorization of 60 is 2, 2, 3, 5.
So 2 to the second power.
Don't use second powers for lowest terms. Leave them spread out because we're going to be canceling them. Okay? Okay, now we're going to do 72. Divided by 2 is 36. Divided by 2 is 18. Oh, we have it up there, right? 18. And then divided by 2 is 9. Divided by 3. 9 divided by 3 is 3. 3 times 3 is 9. So we have 2, 2, 2, and then 3, 3. 2, bless you. Bless you. Okay, now using that we can cancel, like divide both top and bottom by 2. Divide by 2, divide by 2. Now we could divide by 3. Divide by 3, divide by 3. See how that leaves 5 on top? 1 times 1 times 1 times 5. We have 5. 1 times 1, okay, 2 times 3 is left. 6.
I'm not sure I totally understand canceling.
You're just dividing the top and bottom by 2. When you cancel these, you divide by 2,
you divide
by
those?
2. Divided by 2, divided by 2. Don't do it sideways. You do a top and a bottom. Top and bottom. It doesn't make 0, it makes 1. Like 2 over 2 is 1, 1, 1. If you cancel everything on top, you would still have a 1 on top. Okay, it doesn't totally go away, it just turns into a 1. So let's do one where it would, like, go ahead and get rid of the top. 18 and 90. Okay, 18 divided by 2 is 9, divided by 3 is 3. So 2, 3, 3. 2 times 3 times 3. There's 9 times 2, that's 18. Now 90, we don't want to divide by 9. 9's not prime.
3.
3 would be an easy one. 3 times 30. 3 again. It's 10. 2 and 5, right? So it's 2, 3, 3, 5. Okay. So divide by 2, right? Divide by 2. Divide by 3. Divide by 3. And then another 3, divided by 3, divided by 3. Okay, on top there's nothing else that can cancel. You have 1 times 1 times 1, it's just 1. So if everything cancels on top, don't just leave it off and say your answer is 5. Your answer is 1/5, not 5.
That's where that one comes in.
So, explain that one more time, Connie, please.
Okay. If you have the 18 and 90, we found the prime factorization is 2, 3, 3, and then the 90 is 2, 3, 3, 5. Okay, now we're going to divide the top and the bottom. Divide 2, divide 2. When we divide 2, we make it 1. 2 divided by 2 is 1. 2 divided by 2 is 1. Divide by 3, divide by 3. Divide by 3, divide by 3. Okay, there's nothing else that we could divide, so we're done. Okay, 1 times 1 times 1 is 1. 1 times 1 times 5 is 5. Okay? So if you have really huge numbers, instead of trying to divide a whole bunch of times and maybe making a mistake on the division, this might be an easier way not to make mistakes. Let's do one, like since you're doing evens, you're going to be doing like number 26. Okay, why don't we do 25 or 27? 25 looks a little harder. We'll do 25. 25 has 96 over 132. Okay, 96 divided by 2 was 48. Okay, and then divided by 2
It's 20.
24, right? Divide that by 2, I hope I have room. It's 12. Divided by 2 is 6. I'm writing little now. Divided by 2 is 3. I barely have room. 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5 2s, and a 3. Okay, I'm going to start lower. 132 divided by 2, okay, into 13, that's 6, that's 12, and then 2 into 12 is 6. Okay, what are we going to divide now? By 2 or 3, right? 411.
So we end up with 1, 2, 3, 4, 5 2s and a 3.
Yeah.
So that would be 2 with the power of 5.
No, don't put
No,
the exponents for, not for reducing, just when it tells you to write it with exponents.
Oh, okay.
It would be 2 to the power of 5, but don't write it that way.
No exponents on reducing,
Okay.
when reducing?
Yeah.
When you're reducing, write them out.
Okay, so the next one we're gonna.
Now we did 132 divided by 2 is 66. Divided by 2 is 33. Divide by 3 is 11. I guess I didn't need as much room as I thought I would need. 2 times 2 times 3 times 11.
You can divide the 11 or more.
Nope, nothing goes into 11, it's a prime.
So you've got 2, 2, 3, 11?
Yeah,
Okay,
so, the top, we're gonna divide
2,
by 2,
2,
bottom by 2,
2,
another 2, and a 3.
You
That's
just,
it, right?
you just change the matching
Yeah.
numbers, divide,
Yeah.
whatever they
Yeah.
go into.
The matching ones get canceled.
So then you've got the 2 times 2 is 4 times 2 is 8.
Right, 2 times 2 is 4, times 2 is 8. So on top you have an 8,
And the
On
bottom is
bottom?
11.
just 11.
Oh.
So this reduces to 8 over 11.
Hallelujah. Okay,
Okay, you want to do one more like this?
so the answer is 1, 2, 3, 4, 8,
And
11.
just a
Yeah.
second.
Yeah, let's do another one.
Okay,
Is it always gonna be like 2 or?
there'll be 2, 3, 5, 7, it'll be primes, because you're prime factoring it.
Yeah, because you won't be able to reduce it anymore once you get it
Actually,
there.
these, it didn't say you had to prime factor. You could have reduced this just by dividing by 2 and, you know, you could have did 96 over 132. You could have divided the top and bottom by 2 because they're both even.
Okay, how were you able to divide 3 into 2 evenly?
You can't.
But you did.
No, she canceled 3 of the 3s.
Yeah.
Where?
She
Oh,
got-
she went all the way over to the end to cancel that 3?
Let 3 choose alone.
Oh. Okay, I thought you had to divide it into the immediate number above it. I'm sorry.
You're dividing by this number on the side.
Mhm.
This number divided by 2 is 66.
No, I was talking about up there.
This one?
Yeah.
Oh, no, I had to divide the 3s here.
You just find what it
I
divides
divided
into,
1,
cancel now.
2, another 2, and then a 3. There wasn't any more 2s down here, so I had to go to the 3s. It doesn't have to be immediately on top of it. Okay, we could have did it divided by 2 was 48. 132 divided by 2 was 66. See, it's still even. We could have divided by 2 here. 48 divided by 2 is 24. 66 divided by 2 is 33. Now,
So
it
I
won't
did-
divide by 2 anymore. Then you have to recognize here that they both divide by 3. If you had it prime factored, you would see the 3s here. Here you have to recognize that you can still divide by 3.
And it would be 811.
Yeah, still be the same answer. But here, you'd have to make sure you'd recognize it and be able to get that. Okay? But the ones, 9 through 28, it doesn't tell you how to do it, so you could do it this way or this way. Okay? On the ones that follow that, 29 or 30 through 34 in your homework, it tells you to write as a product of primes. So you have to do those this way. Read the directions and see if it tells you how you have to do it. Because from 30
And that's
through
how writing
34,
is
you
a
have to write it, actually all the way to 38. You
And
have
that's
to
how
write
wri-
as a product of primes and then do the canceling.
Yeah, and 10 too, because it says write each fraction in its lowest term, so
Well,
that's
it doesn't matter how you do it though. On number 10, it just says to do it. So, like number 10, it says 6/12. You can write as a product of primes, or you could just divide by the number you want to divide by. So if you see the number you could divide by, do it the simpler way. Go ahead and say, oh, I'll divide by 6. I'm dividing by 6 on the top and bottom, so I got 6 divided by 6.
1,
12,
2.
yeah, 12 divided by 6 is 2.
And that's it.
Yeah, you can do it that way.
All of
Okay.
them. From up
Well,
here.
not all of them. Up to 28, you could do it either way. Up
to 28, you do it either way, but.
Right, and then from 30 to 38, you have to do the product of prime way.
So that one was
From
1/2,
30
yeah.
through 38, you have to do this way. Those problems on your homework, you have to do with the product of primes.
With the what?
The product of primes, do the prime factoring way,
Oh, okay.
okay? And then there's a little more on your homework here. It tells you to state whether a fraction is equivalent to another fraction. Okay, let me tell you how to do that. You can either reduce both of them. Like if you have, you know that 1/2 is equivalent to 5/10, right? You already know 5/10 is a half? Okay. When they are equal, if you multiply, it's called cross products. If you multiply across, 10 times 1 is 10, 2 times 5 is 10. Their cross products will be equal. Okay? So you can either multiply across, if you get the same number, you know that the fractions are equal. But we know that a half is not equal to 3/4. Okay? We already know that, but let's do the cross products. 4 times 1 is 4. 2 times 3 is 6. See, the cross products are not equal, so this is not equal. And that's all you have to write on your answer column, is either the equal or the not equal side. Okay?
On the answer?
Okay,
On
that's
the
how you
answer
do,
column.
that's how you do all those?
Yeah,
Okay.
from 39 through 50, 40 through 50 on your homework?
Okay.
40 through 50?
Yeah. Okay, or that's one way to
39
do it.
to 50.
Okay, let me show you another way you can see if they're equal, okay? On 39, you have the two fractions 3/6 and 18 over 36. You can either do the cross products, which you're multiplying kind of big numbers, or you can reduce both of them. You could do 3/6, and then if you divide by the same number, you end up with a half. So 3/6 is the same as a half. Okay, if you do 18 over 36, go ahead and reduce it to lowest terms. Let's see, divide by 9, you have 2/4. Divide by 2, oh, we have a half again. See, if they reduce all the way down to the exact same fraction, then you know they're equal.
It's a little bit longer, isn't it? Isn't it longer that way?
Yeah, probably.
So we could just cross.
So you either need to show me that you reduced them, or show me that you multiplied and have numbers up here. That's showing your work on it. You're showing what you came out with when you multiplied, or showing that they're equal fractions.
How about reducing it like to 1/2 and then noticing that 36 times 1 is 36 and 18 times 2 is 36. Can you stop there, or, you know what I mean? Like,
Yeah. Well, reduce it to the lowest term. Actually, the directions tell you to reduce in the lowest terms to see if they're equivalent. It wants you to reduce it to lowest terms and find these two, but I showed you how to do it this way, so if you want to do it this way, I'll let you do it this way. Okay? Or you could follow the directions and do it in lowest terms. Either way. I'll let you do it either way.
Okay.
And I believe that's all for the homework, because that's the two sections that are due.
Okay,
Yes.
okay, I did 40. Okay, I multiplied 72 times 3, which is 216. 27 times 8, which is 216. Okay, there.
Okay, so they're equal.
So I only have to put equal down as my answer.
If you multiply the cost and it came out equal, you show the number up here that you got, then you're done. You just put an equal sign, and in the answer column, you just put equal.
So that doesn't reduce down to anything?
Actually, the 27 over 72 is going to reduce to 3/8. On number 40, you have 3/8, which will not reduce. You have 27 over 72. These will both divide by 9, right? 27 divided by 9 is 3. 72 divided by 9 is 8. See how this reduced to the same fraction as that?
Oh, wow. And the 38, we don't do nothing to it? Yes.
38?
I mean,
3/8, it won't reduce.
Okay, duh.
Yeah. On 41, you have a 10 over 24 and a 12 over 30. See, what can we divide these by? We divide by 2. And you have 5 over 12.
Oh, so the answer ends up to 3/8 because they're exactly the same. So the 2772 is 3/8 too.
Right. This one reduced to 3/8.
Oh,
So it's equal. This one, let's divide this by 2. You have 6 over 15. Oh, we could divide again now. Divide by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. Both of these are totally reduced. They're not the same. So it would be not equal.
Oh, I so got it. Kind of.
Okay? It actually wants you to reduce everything. Is what it really wants you to do, so you get practice at reducing. Okay? Is there any more questions?
Just one small one.
What?
The equal and the equal sign, the two equal signs and the one you have across through, does that mean one is equivalent and one is not equivalent?
Yeah. The one, like this one right here, when we did that, they were equal. So this is equal. If they didn't come out the same, this is not equal. See, these two fractions are not the same. So they are not equal. Kind of like, what do you call it? What do you want to call? Ghostbusters? We're busting the ghosts. No ghosts. That not, this does not, right there.
That's a new symbol then.
Yeah.
A new symbol. You'll probably have a not equal sign on your new symbols at the end.